welcome to Chapter 1, Part 2 video. This is covering 1.4, 1.5, and 1.7. We will not be covering 1.6. So starting with Chapter 1.4, our objective is to find and compare the measure of angles. And so this whole section, and really the next couple sections, are about angles. So first we have to know, what is an angle? An angle is made up of two rays with the same endpoint. So for example, here we have a point A and then two rays that extend out from that endpoint. Okay, and we can name this angle by its vertex, angle A. And sometimes we put a little mark here so that you know that it's not an L. But either way, with or without the mark, this is the angle symbol. So that's angle A. But if this had another angle coming out of it, let's say there was another ray here, then we can't call it angle A anymore because now there are two different angles here, okay? If there's only one angle, then we can call it angle A. The rays are the sides of the angle, right? Each side of the angle is made up of a ray. And the endpoint, the point that these two rays have in common, that is called the vertex. Okay, so this is side, vertex, side. In this case, our vertex is A, and the sides are these two rays, which are ray AB and ray AC. Okay, so we said A, the vertex is A, so we can call it angle A, and then a point on each ray and the vertex is how we can name, another way to name the angle. So we say B through the vertex C, so that's angle BAC, or we can go the other way around, CAB, angle CAB. Okay, notice A is in the middle both times because A is the vertex. So the vertex must go in the middle. The other way we can name this angle is, see how it has a little number 1 in the middle? So we can call it angle 1. Okay, but if there's not a little number 1, we can't call it angle 1. We have to number the angle before we can name it that way. Okay, so here, if we're looking at this angle MOP, we can call this angle O because there's only one angle through vertex O. However, this one, we have angle HAM and MAT, so we cannot call this angle A because which one are we referring to? So we don't call that angle A. Let's look at a couple more definitions here. So when we're looking at an angle, this is the vertex, these are the sides, and then we have the inside and the outside of the angle. This is called the interior, and this is the exterior. So the part that's smaller is the interior, the part that's larger is the exterior. Think about like the inside of a crocodile's mouth, interior. So the interior of the angle is the region containing all the points between the two sides of the angles, interior. And the exterior of the angle is the region containing all of the points outside of that angle. So this is exterior. So let's practice some of these definitions. What are two other names for angle 1? So here's angle 1. Can we call it angle M? No, because there are two angles here. So we cannot call it angle M. We can call it angle JMK. JMK makes angle 1, right? So angle JMK. We can also do the other way, KMJ. Angle KMJ. Okay. Can you name the angle M? No, we already said this because, yes, because there are two angles with vertex M. Let's take a look at the next page. So now that we have some vocabulary to talk about angles, remember our objective is to talk about the measurement of angles as well, so we want to be able to measure these angles. So if we have a protractor, And this is the tool that we're going to use to measure angles. And the way we do that is we set up one ray to be along this bottom line at 0 degrees. And we set up the second ray to be along the inside of the protractor. And then the protractor will tell you how far around the edge the angle goes, and that gives you the angle measure. So we're going to say this starts at 0. So we're reading on the inside numbers, it goes up to 60. If our angle's facing the other way, we still start it at 0. Notice the 0 is on the outside edge this time. And so that angle goes out to 70 degrees. Okay, so let's talk about some of these terms. So when we're looking at the angle, we had just the angle symbol. Now we're talking about the measurement of the angle, we put a little m in front of it. So when we have m angle, that means the measurement of the angle. So for example, if I said the measurement of angle A, this would be the measurement of angle A is the vertex. Okay, so any of the ways that we just talked about for naming angles could go in there. So let's find, what is the measurement of angle 2? We said is 60 degrees. Important to put that degree symbol. What is the measurement of angle 3? We said that was 70 degrees. So let's look at some options for what the measurement tells us. How do you classify an angle? This angle is sharp. It's a small angle. And the way we classify small is that it's less than a right angle. So the first thing I'm actually going to define here is a right angle. This angle is 90 degrees. It's kind of our standard angle that we compare things to. So this is a right angle, and a right angle is always 90 degrees. Always, always, if it's a right angle. We cannot assume that angles are right unless it has that little symbol, and the little symbol means that it's a right angle, or if it gives you the angle measurement. So in this case, that's definitely smaller than 90 degrees. This is called an acute angle. It's small, it's so cute, it's acute. Okay, so here we have the measurement of angle CAT is less than 90 and bigger than 0. Here we have our angle RYM is equal to 90 degrees. Here we have an angle that from 90 degrees, it didn't decrease, it actually increased, it got bigger, it got wider. That is called an obtuse angle. So the measurement of angle POM between 90 and 180, and 180 is half of a circle, so that's a flat line. So we're going to define that in a second. And so those are the numbers that define an obtuse angle. And so finally we have our straight angle, which makes a straight line, and a straight line has 180 degree measurement. So from one ray around to the other ray is 180 degrees, and that's half of the circle. So just like before, we have this difference between talking about things being congruent or equal. In this case, congruent, we're talking about angles now. So if an angle has the same measurement, the same size, then we call it congruent, whereas again, this is just numbers. So this is a measurement, and we can use the word equal. So if these two angles have the same measurement, then we can say angle A is equal. So the measurement of angle A is equal to the measurement of angle X. For congruent, we say angle A is congruent to angle X. So the shapes are congruent, their measurements are equal. So let's look if we can apply this. We want to mark OMA congruent to SIN. So remember, for segments, we did little hash marks. We're going to do the same thing here, but they're going to be little angle marks. So we find OMA, and we put one arc, is congruent to SIN, one little mark. If those two are congruent, then their angle must be the same, so this must be 51 degrees. HIT is congruent Now it's not congruent to the ones we marked before, so just like we put 2 tick marks, now we put 2 angle marks. Congruent to TIS, so here we're going to put 2 angle marks. If they're congruent, their measurement is the same, so this is 30 degrees. So then we say, okay, then what is the measurement of angle ANO? We said that's 51 degrees. And the measurement of angle HIS, well, HIS is both of those angles, so we have to add them up. 30 plus 30 equals 60, so that is 60 degrees. Let's keep going. We actually just did this without having postulated it first, but just like with segments, if we have 2 angles right next to each other, we can add them up to get the bigger one. So AOB plus BOC, so we have the orange one plus the blue one, should give us AOC. AOB plus BOC equals AOC. Little plus little is big, same as with segments. So let's see if we can apply it. The measure of HIJ is 110. So the big one is 110. KIJ is 40 degrees, and we want to find HIK. Okay, so let's call this X degrees. Then I can say little plus little is big. So I can say measure of angle HIK plus measure of angle KIJ equals, actually let me rewrite this on one line. Measure of angle HIK plus measure of angle KIJ equals measure of angle HIJ. HIK, that's our unknown. KIJ is our 40 degrees. And HIJ, that was our big one, is 110 degrees. So to solve for X, I need to subtract. So X degrees, 110 minus 40 is 70 degrees. But I don't want X, I want the measurement of HIK. Well, X is the measurement of HIK, so the measurement of angle HIK equals 70 degrees. Notice how I went back in order to find the question being asked. Explain, we use the angle addition postulate. For the next example, we have P is on the interior of angle JAM. So here we have angle JAM. P is on the interior. So anywhere inside here, there's point P, which means there's another ray between A and P that we could draw. So we have angle PAJ is 7x minus 1 degrees. MAP is 4x minus 3 degrees. And we know that JAM, which is our big angle, is 95 degrees. So we want to find the measurement of angle MAP. Let's start by saying little plus little is big. So we have 7x minus 1 plus 4x minus 3 equals 95 degrees. Combining like terms, 7 plus 4 is 11x. Minus 1 minus 3 is minus 4 equals 95. Plus 4, 11x equals 99. Divided by 11, x equals 9 degrees. Okay, these are all in degrees. And so x equals 9, but that wasn't the question. The question is for the angle of MAP. So we have MAP has a measurement of 4x minus 3, 4 times 9 minus 3, 36 minus 3, which is 33 degrees. Okay, and again, this was by angle addition postulate. Okay, our last example here. Angle RQT is a straight angle. That tells me this is a straight line. If it looks like a straight line, there's no bend in it at all, then you can always assume it's a straight angle. What are the measurement of angle RQS and TQS? Well, what do we know about a straight angle? We know that a straight angle is 180 degrees. So that means measurement of angle RQT is 180 degrees, which means that if we add up the two little angles, it should add up to 180. So 11x plus 1 plus 8x plus 8 equals 180. Collecting like terms, we find that 19x plus 9 equals 180 minus 9, 19x equals 171. Divide by 19, x equals 9. That was not the question. The question isn't x, the question is the angle measurements. So the measure of angle RQS equals 11x plus 1, 11 times 9 plus 1, 99 plus 1 is 100. And then there are two ways that we can find the measurement of angle TQS. We can substitute in, or we can say, well, they have to add up to 180. So what do we have to add to 100? Measurement of angle SQT equals 180 minus 100, which is 80 degrees. So we used, again, the angle addition postulate in order to solve for the two missing angles. Moving on to the next page, section 1.5, more information about angles, but our objective here is to identify special angle pairs and their relationships in order to find angle measurements. So we defined angles, we looked at some vocabulary to use, and we looked at how to measure the angle of, or how to take the measure of an angle. Now we're looking at special angles. So the first pair of special angles is two angles with a common vertex. We've seen some examples of this where they have a common vertex, and what makes it special is they also have a common side. So what this looks like is I have a vertex, here's one angle, and here's a second angle that shares the side. Okay, so they have a common vertex and a common side. We have angle 1 and angle 2 here. And the special relationship that they have is what we were just talking about when we add angles. So we can say the measurement of angle 1 plus the measurement of angle 2 equals, and we're going to call this ABC, the measurement of angle ABC. Okay, this is also called the angle addition postulate. Then we have vertical angles. Vertical angles are angles whose sides are opposite rays. So what this is I have a line and I have another line, because remember, opposite rays make lines. And the angles that are made up of those same two lines are called vertical angles. 1 and 2 are vertical angles. We can also say that 3 and 4 are vertical angles. But 1 and 4, notice they share a common side, are not vertical angles. Their special relationship, we can say the measure of angle 1 is equal to the measure of angle 2. We can say the measure of angle 3 is equal to the measure of angle 4. Another way of saying the same thing is that angle 1 is congruent to angle 2, or angle 3 is congruent to angle 4. So vertical angles are congruent. Next, we're going to look at complementary angles. So complementary angles are angles whose sum is 90 degrees. So together they make a right angle. They could be separate angles or they can be adjacent angles, but the important thing is that they add up to 90 degrees. So if we have angle 1 and angle 2, we can say the measure of angle 1 plus the measure of angle 2 always has to be 90 degrees. No matter what position they're in, if they are separate angles or adjacent angles, they have to add up to 90 degrees in order to be complementary. And then supplementary, very, very similar, except instead of adding up to a right angle, it adds up to a straight angle of 180 degrees. And again, they can be separate, they could be adjacent. But if we call this angle 1 and this angle 2, then the measurement of angle 1 plus the measurement of angle 2 has to add up to a straight angle, which is 180 degrees. Okay, these two, you just need to practice remembering the word with the value. Complementary means 90, supplementary means 180. They are quite easy to confuse with each other. Okay, so let's look at some true or false questions. Is angle BFD and angle CFD adjacent angles? BFD and CFD, are they adjacent? So this one and this one. Notice how angle CFD is inside of angle BFD. They're not adjacent because one is inside the other. So this is false. Angle CFD is inside angle BFD. Remember, adjacent means next to. So we're looking for adjacent angles to be two angles that are next to each other. 2. AFB and EFD. AFB and EFD, are they vertical? So the question for vertical angles, are they made up of the same two lines? Well, there's one line, but this is not a line. See how it curves? So this is false. BFB are not collinear. Or we could say they're not opposite rays. So F4, FB and FE are not opposite rays. And then finally, AFE and BFC, are they supplementary? Supplementary means 180. So AFE is 62, BFC is 28, 60, 70, 80, 90 degrees. So this is false. They are complementary. Okay, let's look at a couple more. All right, for number 4, we have a diagram. The measure of RST is 6x plus 5. The measure of TSQ is 5x minus 3. We want to solve for x. Well, do we have enough information here? Yeah, there's one more thing that we have that was not mentioned in words, which is this little symbol here, which means that this is a right angle. If this is a right angle, then these two angles are complementary. Complementary, which means 6x plus 5 plus 5x minus 3 equals 90. And I should be drawing my degree symbols to be clear that those are angle measures. Okay, so I know that they have to add up to 90. 6x plus 5x is 11x, plus 5 minus 3 is plus 2 equals 90, minus 2, 11x equals 88, divide by 11, x equals 8. Solve for x, I did, x equals 8. Number 5, given angle C and angle D are supplementary. Supplementary is 180. If the measure of angle C is 10x minus 4 and measure of angle D is 6x plus 8, solve for x and explain, then find measure of angle D. So angle C and angle D are supplementary, means they add up to 180. So now we have 10x minus 4 plus 6x plus 8 equals 180. We want to solve for x and explain. So this is supplementary. 10 plus 6 is 16x. Negative 4 plus 8 is plus 4. Equals 180 minus 4. 16x equals 176. Divide by 16, that is 11. Okay, so now we use the definition of supplementary angles to find that x is 11. And then we also want to find the measure of angle D. Well, the measure of angle D is 6x plus 8. 6 times x plus 8. 66 plus 8 gives us 74 degrees for the measurement of angle D. So we've got two parts to our answer here. Let's keep going. So we have some angle relationships that you can assume from a diagram that has no marks or measures. Some examples are vertical angles. Okay? Others you cannot assume. They need to be marked and they need to be told to you specifically. So there are, the big difference here is that really the only assumption you can make is lines are straight. And the properties that come out from lines being straight. So which of these can you assume to be true? If I have angles that look adjacent, can they not be adjacent? Well, as long as lines are straight and they share a point, we can know that these angles are adjacent. Adjacent and supplementary. Well, that would mean supplementary means they make a straight line. So anything that looks like that, does it have to be supplementary? Yes, because lines have to be straight. Angles are vertical angles. Well, if all lines that are straight can be assumed to be straight, then those two angles must be vertical of each other. So yes, we can assume that. Angles and segments are congruent. Well, if I have something marked like this, can I assume that those are congruent? No, because that doesn't come from a line being straight. It has to have the tick marks. An angle is a right angle. Well, what if that is not marked? It could be 91 degrees. It's not a straight line. We cannot assume it. Angles are complementary. Same thing. If I have two angles like that, that looks like a right angle. If it's not marked, you cannot assume it. The only thing you can assume is that lines are straight. So let's use the figure to see if we can answer these questions. Angle 3 and angle 5 are vertical angles. Angle 3 and angle 5, they're made up of two lines, so yes. Made from two intersecting lines, or pairs of opposite rays. Angle 1 is congruent to angle 2. Yes, because it's marked. If it was not marked, then we cannot assume. Even though they look the same, that's not an excuse to assume information. How about if segment PW is congruent to segment QW? PW and QW. These vertical segments are marked as congruent. These ones are not, so no. No congruence marks. How about B? W bisects TV. W bisects TV. Yes, because of those congruent marks, we know W is in the very middle, and therefore it bisects. Yes, congruence marks. TWQ is a right angle. Do we have any information that says that that's 90 degrees? No. No markings or angle measures. All right, let's look at some more postulates. So our next definition that we want to look at is the definition of a linear pair. And the way we define a linear pair is that we have two adjacent angles, so angles that are next to each other that form a straight line. So remember when we were looking at supplementary angles and we said they could be together or not together? Well, if they are together, then they're called a linear pair. So together they make a straight angle. So in this picture that we have linear pairs here. 1 and 2 are a linear pair because together they make a straight line. So if two angles form a linear pair, then they have to be supplementary, which means that when we add them up, they equal 180 degrees. So let's see if we can identify some linear pairs. In this diagram, are 1 and 2 a linear pair? Well, the way we can look at it is we say if we go through angles 1 and 2 together, does it make a straight line? Yes. How about angle 5 and 3? Well, angle 5 and 3 are not even adjacent, so they can't be a linear pair. Angle 4 is between them, so no, this is not a linear pair. How about angles 2 and 3? I can go through angles 2 and 3 and it makes a straight line. So yes, these are a linear pair. 4 and 5, they are adjacent, but when I go through both angles, notice that does not make a straight line. So no, these are not a linear pair. 1 and 3, they're not adjacent, so they cannot be a linear pair. 4 and 3, they are adjacent, but together they don't make a straight line, so no, these are not a linear pair. Now those are not congruence marks, they were just for me to help show you which angle we were looking at. Okay, so I'm going to go ahead and erase them so that you know they're not congruence marks. Our next definition that we want to look at is an angle bisector. Now the reason we're looking at all of these special angles and their relationships is because we're building up to be able to find additional properties. Okay, so we want to define an angle bisector very similar to a segment bisector. Bisector still means to cut in half. Cuts it exactly into two equal pieces. So a ray that divides an angle into two congruent angles, its endpoint is at the same vertex, and then we have a ray coming out, and so we have two angles that we can mark as congruent. If we know that AF is an angle bisector, then the angles on either side of it have to be congruent. So let's see if we can use this. If angle AC bisects angle DAB, and the measure of angle DAC is 58, what is the measure of angle DAB? Okay, well, because this is bisecting, we know it's two equal pieces, which means that this angle is also 58 degrees. And with the segment addition postulate, or sorry, the angle addition postulate, we know that the measurement of angle DAB is the sum of its smaller angles. Measurement of angle DAC plus the measurement of angle CAB. And so we can say 58 plus 58, which is 116. Okay. Because they're congruent, you can also say they have the same measurement, so it's 2 times 58. Notice it's the same. If I add 58 plus 58, it's the same as 2 times 58. We have two angles with the same measurement. Okay, so let's look back at some of these things that we've talked about. Which of the following points are coplanar? Coplanar means in the same plane. So NRS, yes. TNW, sure, it's in the vertical plane together. VNR, yes. VT, no. So when I'm asking if they're coplanar, I mean if they're coplanar on the given planes. Okay? Number 2, if the measurement of angle RSU is 6x minus 2 degrees, and RST is 7x degrees, then solve for x and angle RST. Well, what do we know about those two angles? Those are a linear pair, so they are supplementary. So we have 6x minus 2 plus 7x equals 180. Collecting like terms, 6 and 7 is 13x minus 2 is 180 plus 2. 13x is 182. Dividing both sides by 13, we get 14. Okay, so x is 14. That's the first part. We also need angle RST's measurement. So we put a little m in front. RST is 7x, which is 7 times 14, which is 98 degrees. So we have x equals 14, and the measure of angle RST is 98 degrees. Moving on to the next page. If the measurement of angle 3 is 45 degrees, notice how every time I get a piece of information, I label it on my diagram. It's very important to do that. Determine which statements are true about the diagram below. Choose all that apply. Angle FEG and FEH are supplementary. Are those two angles supplementary? Yes. Angle 3 can also be referred to as angle E. No, there are more than one angle with that vertex. Angle 3 and 4 are complementary. This one is a little difficult because our immediate instinct is to say, well, no, those are vertical angles, so they're congruent, but 45 and 45 together does make 90. So this is yes, because 45 and 45 is 90, not because because they're vertical. The measurement of FEH is 135. FEH, so we want to find this angle measurement here, which is 180 minus 45, which is 135. So this is yes. And segment GE equals segment EH. We have nothing to base that off of. We have no segment lengths at all. So this is no. On number 5, P is in the interior of angle LAM. LAM with P in the middle. If the measurement of angle LAP is 4x minus 5 degrees, and the measurement of angle PAM is 6x plus 3 degrees, measurement of LAM, that's our big angle, is 88 degrees. Solve for x, explain, then solve for PAM. So first thing I'm going to do, I have two adjacent angles and the big angle measurement, so I'm going to use angle addition postulate to say 4x minus 5 plus 6x plus 3 equals 88. 6 and 4 is 10x minus 5 plus 3 is minus 2 equals 88. Plus 2, 10x is 90 divided by 10, x is 9. So that's the first step. And find measurement of angle PAM. I'm going to just go below the box. Measurement of angle PAM. PAM is 6x plus 3. 6 times 9 plus 3. 54 plus 3 is 57 degrees. Measurement of angle PAM. Okay, and then our last one, solve for x, explain. So here, all we have is this diagram, but we do know that we can assume straight lines are straight. So that means that that angle that I just drew in is a straight angle, which means that these two are supplementary. They are a linear pair. So we have 5x, sorry about that. Okay, 5x minus 17 plus 7x minus 7 equals 180. Collecting like terms, 12x minus 17 and 7 gives 24 equals 180 plus 24 plus 24. 12x equals 204 divided by 12. X equals 17. I'm not looking, I am looking for x, but I'm also looking for these two angles. So 7 times 17 minus 7. 7 times 17 is 119. Minus 7 is 112. And 5 times 17 minus 17 equals, 5 times 17 is 85 minus 17, which is 68 degrees. Now these two should add up to 180. 170 and 10 is 180, so it worked out. All right, let's keep going. Midpoint, just like it sounds, is a point in the middle. Distance, hopefully you've seen it before. We can talk about the distance between 2 points, and we are going to be using Pythagorean theorem for that. So our objective for this section is to be able to find the midpoint of a segment and also to be able to find the distance between 2 points in the coordinate plane. So remember, a segment bisector is a ray, a line, or a segment that divides a segment into congruent segments. Segment bisector is cutting a segment in half. An angle bisector is a ray, a line, or a segment that divides an angle into two congruent angles. Now, it may seem silly that I'm emphasizing this so much. However, it's very common to be told that you have a segment bisector and then try to use that to cut an angle in half. So I want you to really pay attention that a segment bisector is cutting a segment in half and an angle bisector is cutting an angle in half. So let's take a look at these practice problems. If we have ray AB bisecting an angle, that means the angle is cut in half. CAD, find the value of x. So if this is a bisecting ray, that means that these two angles are congruent. If it's cut in half, then the two halves have to be equal. And so we know that 33 degrees is equal to 4x plus 1 degrees, right? It created two congruent angles, so their measurements are equal. Subtract 1 from both sides. 32 equals 4x. Divide by 4. 8 equals x. So what is the value of x? It is 8, but we can't find it unless we recognize that the bisector creates two congruent angles, which means that their measurements are equal. In part 2, given that line L bisects segment AB and that AO is 7x plus 10 and OB is 9x minus 2, we want to find x. Well, if the line L bisects the segment, then it creates two congruent segments. L doesn't become two congruent parts. L is cutting AB into two congruent parts. And so we have 7x plus 10 equals 9x minus 2. Subtract 7x from both sides. Add 2 to both sides. So we have 12 equals 2x. Divide by 2, 6 equals x. So again, using that term of bisecting to show that we end up with two equal parts. Okay, so what's the difference between these problems? And this is the same thing that I've been emphasizing. The difference between these is that one is cutting a segment in half, one is cutting an angle in half. Okay, so in both cases, we have an object being cut in half, creating two congruent pieces. First, an angle bisector creates two congruent angles. And second, we have a segment bisector creates two congruent segments. Okay. So if we're bisecting, we're cutting through the midpoint. So how do we find a midpoint? So in order to find the midpoint and the distance, we're going to look at this graph. Okay. So suppose we wanted to know the distance between the town of Davenport and Everett. How do we find that? Well, in order to find the distance between these 2 points, we can find the length of the line segment. So in order to find the distance, we want to find the length of the line segment between them. And we're going to talk about exactly how to do that. And then the second question here, what if you stop halfway for a snack? What would your coordinates on the graph be? Well, if we wanted to stop halfway, somewhere right around here is halfway, and I can estimate it, right? But what I'm looking for is what is the midpoint between Davenport and Everett. So halfway would be the midpoint, which looks to be around, if each line is 2, right, from here to here is 4, so each line is 2, so that looks to be about 1,7.5. And that's just an estimate. Right now we're just looking at the estimate, and we're going to calculate the exact values by the end of this section. So let's take a look at the next page. Let's talk about midpoint first. So the midpoint of a segment is a point that divides the segment into 2 congruent segments. So recall, if we wanted to find the length of a segment using coordinates, for example, the distance from A to D is what we've seen before, we need to find the absolute value of the difference between the points. So if we wanted to find CF, the distance between C and F, we need to find CF equals the absolute value of C minus F. Our value for C is -1. Our value for F is 5. -1 minus 5 is -6. And the absolute value of -6 is 6. Now we want to find the midpoint of segment CF. So what is the point in the middle? Well, if CF is 6 units long, then halfway in between is 3 units. Half of CF is 3, which means we need to be 3 units away from the end. So from 5, I can go 1, 2, 3 units away. And so 2 should be the midpoint. And it should be the same distance from C. From C, I can go 1, 2, 3 units away. Okay, so how can we find this arithmetically or mathematically? How can we calculate this? And the way we calculate it is we actually find the average. Now to find an average, like if you're trying to calculate an average grade, you add them together and divide by 2, and that's what we're going to do. So we're going to say C plus F over 2. So C was -1, F is 5, and this time we're adding over 2. 5 minus 1 is 4, over 2 is 2. And that is our midpoint M. So that's how we can do it for a number line. And that's the steps for that are written here, midpoint formula for a number line. So to find the coordinate of the midpoint, we find the average, which is also called the mean, of the coordinates of the endpoints. So to find the midpoint of AB, we add A plus B over 2, where A and B represent the coordinates of A and B, points A and B. So what I'd like you to do is go ahead and try number 1 and number 2 here. Pause the video, and then we'll go over them during our synchronous class time. If we're working in 2 dimensions, so in a coordinate plane now instead of just a number line, then we have a slightly different formula. The calculation is the same, but now in a coordinate plane, so think about plotting on a graph, the coordinates of a midpoint is the average of the x's, and then separately we calculate the average of the y's. We're going to practice this. So if we have a segment AB, where point A is at x1, y1, so that's our first point. Point B is at x2, y2, that'll be our second point. Then the midpoint is the average of the x's and the average of the y's. Let's look at an example. Even though this says try this, we're going to do it together. So first we want to find segment EF that has endpoints 7, 5, and 2, -4. And then we want to find the coordinates of the midpoint. So first let's plot E. So we count 7, 1, 2, 3, 4, 5, 6, 7, and then 5, 1, 2, 3, 4, 5. There is point E. And then we have 2, -4 is point F. So we plot those points, and then we want to find the coordinates of the midpoint. So if I'm looking, well, that wasn't perfectly straight, but there's my line segment. To find the midpoint, the point in the middle, should be somewhere around here. The midpoint is going to be the average of the x's and the average of the y's. So I like to do my calculations separately. Here are my x's, here are my y's. 7 plus 2 over 2, 5 plus -4 over 2. So we have 9 over 2, which is 4.5. 5 minus 4 is 1/2, which is 0.5. So the midpoint is 4.5, 0.5. Notice I calculated the average of the x's, and that became my new x value. The average of the y's became my new y value. 2, 4.5, and a half. There is the midpoint, M. Okay, on part 2, and we are also going to do this together. On part 2, we're given the midpoint and one of the endpoints, and we want to find the other endpoint. So we kind of have to use that equation that we just used, but we're doing it backwards. So notice we had the midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. And so now we have the x of the midpoint and the y of the midpoint. We have x1 and y1, but we don't have x2 and y2. That's what we're looking for. So let's call point D x2, comma, y2. Then we know that -2, which is the midpoint, equals x1, -5, plus x2, which we don't know, over 2. And we know that the y value of our midpoint, which is 1, equals y1, which we know is 7, plus y2 over 2. It might help to set it up here. If you wanted to call your midpoint, this would be your midpoint x and y, so that you can see that we're really using the exact same equation, but we had an unknown that was already isolated before. Now we need to isolate our unknowns. So how do we do that? Well, we need to solve, let's solve for x first. So multiply both sides by 2. Negative 4 equals negative 5 plus x2, plus 5 plus 5, 1 equals x2. Same thing on this side, times 2, so 2 equals 7 plus y2, minus 7 minus 7, negative 5 equals y sub 2. Now this is not a distance, so it can be negative, and so we have that point D is at 1 comma negative 5. Okay, so that's midpoint and using midpoint. Next, we'd like to talk about distance. So the distance formula, you might have seen this before. It comes from the Pythagorean theorem. Pythagorean theorem, which states a squared plus b squared equals c squared. I'm not going to derive the whole thing for you. So let's see if we can find the distance between m and c. So let's start by writing the formula. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And then we need to plug in our values. I like to write, here's x1, y1, x2, y2. This is not x1 and x2, right? It's x and y of our first point. I'm saying that because it's a trap that we can easily fall into. So here, x2 is negative 5, x1 is 6, plus y2 is 3, y1 is minus negative 2. Negative 5 minus 6 is negative 11. Negative 3 minus a negative 2 becomes positive, so that becomes 5 squared, all under a square root. 11 squared is 121. 5 squared is 25. 121 plus 25 is 146. And then it says round to the nearest tenth, so we'll put this into the calculator. The square root button is right here next to x squared. So if you look at 7 and you go up and over 1, there's the square root. We have to press second, square root, and it'll put a little square root symbol. 146, close parentheses, enter. And so it's 12 point, rounded to the nearest 10, 12.1. Okay, and then our last practice problem for this video. What is the distance between these 2 points? Leave an exact answer, so we're not going to estimate it this time. Distance is the square root of x2 minus x1 squared plus y2 minus y1 squared, which is the square root of x1, y1, x2, y2. Negative 1 minus a negative 1. I'm going to go ahead and switch it right away. Minus a negative, it becomes positive. Plus y2, negative 3, minus a negative 11 squared, which equals zero squared plus negative 3 plus 11 is 8 squared. 0 squared is just 0. So this is 64. And the square root of 64, think about what number times itself is 64. Well, we actually had the answer before, and that is 8. The square root of 8 squared is 8. If you're not sure, you can always put that in your calculator. And so our answer is 8. The last page is a try this. Okay, and I'm just gonna kind of show you how to start it because I'd like everyone to use the same coordinates. And so this is that example we were looking at earlier, but we're gonna calculate the exact distance and midpoint this time. And so for Davenport, we're using the coordinates. So each line represents 2. So 2, 4. And then halfway in between is 5, comma, and then it goes up to 8, and one more line is 10. And then for Everett, the coordinates we'll use are -3, comma, and we go up to 5. So you use 5, 10, and -3, 5.